The Big Bang occurred approximately nearly 13.75 billion years ago, and it was responsible for the creation of the universe. But after Big Bang, universe was a gigantic soup of particles racing around the speed of the light without any mass to speak of. That's where Higgs field becomes into the picture. So Higgs field is the invisible energy field that exists throughout the universe, and it consists of Higgs boson particles. Those are known as God particles. And when the particles are scattered from Big Bang, crosses the Higgs field, the former attains the mass and slow down as the weight increases. That means whenever the particle's weight increases, it slows down the movement around it. And if Higgs didn't provide mass to the particles, then all particles will float on the universe the speed of light, and there will be no any gravity and there won't be any life. And more interaction of particles of Higgs fields gives heavier masses of the particles, and that will be equal to settle down at one place. That means creation of stars and planets. Now stars and planets are created due to this settle down at one place only. And what happened again? The Higgs boson was termed after two scientists, Peter Higgs, and one more name is there about Satyendra Nath Bose. So these two scientists worked about that. Then what is about Higgs then? Higgs. So who is this Higgs means here? This person that means he is otherwise called as Peter Ware Higgs. His full name is Peter Ware Higgs. And again, he belongs to England. And he was England physicist, that is British physicist. And he awarded a Nobel Prize in the year 2013 in the field of physics for proposing that presence of Higgs boson. That means presence of this God particle. He received that. And BOSE. About BOSE to talk, the work that was done by BOSE and Albert Einstein led to the foundation of the discovery of God particle. And the subatomic particle called as boson, named after Bengali physicist called as Satyendranath Bose, pioneering that work in the field in early 1920s, if you remember. And it changed the way of particle physics was studied. He was awarded India's second highest civilian award called as Padma Vibhushan by Government of India. And it was noted that he never received any PhD and was awarded a Nobel Prize. Through Nobel Committee recognized other scientists for research related to concepts that he developed. So without PhD, this was the first person to receive Nobel Prize from India. And if you think about the God particle and the universe, what does Stephen Hawking said? You know that his person was a scientist, and later he was a theoretical physicist. He is called as theoretical physicist, and he warned that God particles could destroy the universe, and that can be destabilized a very high energy level above 100 billion GeV. And he also said that Higgs field in two states, one is normal state and the other one is very denser than normal state, he said, and each state will undergo the transition of another state, and however they are separated by energy barrier. And quantum physics experiments can explain or allow particles on one side to break the energy barrier and reach the other side. So this could be dangerous and could destroy the entire universe. This was said by Stephen Hawking. That means energy can flow from that means it can transition from one region to another region by breaking the energy barrier. If that happens, entire universe will be collapsed. Then what is about a standard model then? So this standard model is a theory of particle physics, and it says all the material around us consists of 12 matter particles, also called as fermions. These 12 particles or matter particles are called as fermions, and the other 11 particles are described by a model have been found only in Higgs particles, but not been found. So there is an organization called as CERN. It is going to try. So what are the particles? So under that only we have come to that general theory of relativity. And what is this general theory, general relativity of theory, or general theory of relativity? That it is the theory of a space and time. And the theory was published by Albert Einstein, the later 1915 only. And central idea was this: general relativity is that the space and the time are two aspects of space-time, and this space-time is curved when there is center of gravity or gravity, energy, momentum. That means here this space and time, which are aspects of space-time, and they are in a curved manner when there is a gravity, energy and momentum. Then here comes about string theory. So what does it explains about that? So it is otherwise called as theory of everything. Theory of everything. And as it tries to explain all the fundamental all the fundamental forces and matters of universe. And this theory is like subatomic particles replaced by strings. And then it is a combination of quantum mechanics and general theory of relativity. So you need to remember that string theory means here it is a quantum mechanics plus general theory of relativity. And previously quantum mechanics and general theory of relativity were in conflict with each other, since quantum materials describes the fundamental particles of stars, while this describes stars, galaxies, universe as a whole. So in this manner it does not make any sense that to have one theory of stars and one theory of subatomic particles. Hence string theory solves this problem, and that can be used to construct unified theories, which will give an explanation for quantum mechanics and relative, that means here general theory of relativity and other forces also. So this will come into the field. Then what is SUSY? It is otherwise called as a supersymmetry. Physicists generally believe that the standard model is incomplete. It is very incomplete, and those could be there will be new particles, and which are supersymmetry partners of known ones, known as such property supersymmetry. Such property supersymmetry. And this SUSY is necessary for ingredient of string theory. So to explain string theory, supersymmetry model is important, and this will discover supersymmetry particles which will strengthen the position of string theory. So it will explain that. Next, dark energy and dark matter. So what does it explains? Everywhere we just listen about dark theory or dark energy or dark matter. This is first was a theoretical concept introduced to explain the expansion of universe, and this energy causes expansion. That means dark energy lead to expansion of the universe, And this dark energy can be found in two ways. First one, it finds the sizes, shapes and distances of what? Of galaxies or their clusters, which changes over time to time. This is one thing. And how it will work, this model? That means dark energy causes clusters of galaxies wherever it is spread out, and these will become more compact. That means more compact, closer. So the rate of contraction and expansion of galactic clusters can show relative strength of this dark energy and dark gravity. And what is about the second one? So first one, about it gives you the size, shapes, distance of galaxies wherever present in the universe, and it also finds that the contact between each galaxy and another galaxy to maintain the force of gravity. And what is the second one? Second one, it finds the distance. It finds the distance of the galaxies. And from Earth, through Earth also it finds by an effect called as Doppler effect. So what is that here? The change in frequency of light waves that can be used to identify distance and speed of the object. So some light will be sent. So that light, how much frequency decreased, that will be calculated and find the distance from the dark matter to the Earth. And again, so if the matter moves very faster, that means any dark matter is there in the universe if it is moving very, very faster. So what can we infer here? That means if a matter moves very faster, so the more redder it appears, red color it appears. You need to remember. So more faster, more red. And also it has a very long wavelength. It also has long wavelength, and hence these red colors spotting in the galaxy using a spectroscope will find long distance that are moving very faster and shows the evidence of dark energy. And also dark matter is the theoretical concept explained that how fast rotating the stars and such other things are confined to the galaxy instead of spreading out. And the dark matter is intermediate matter that is necessary to hold near matters together. So this you need to remember. And what is about the antimatter? Antimatter comes with a term used called as a particle physics. In particle physics it will be discussed, and it is a material composed of antiparticles. Antiparticles. These have same mass as particles of ordinary matter, but have opposite charge and properties. And properties such as lepton and baryon number, these will be differed. Lepton, baryon number will be differed, as these are the properties of antimatter. And these encounters between the particles, if you see matter and antimatter, you can see proton is there here, antiproton is there, electron, positron is there, hydrogen, antihydrogen. So differentiation will be seen, and these encountering of the particles between particles and antiparticles lead to the destruction of both. Example, this positron is an antimatter of electron. This antiproton is an antimatter to proton. This antihydrogen is the antimatter of hydrogen. For example, in hospitals, radioactive molecules will be there. They emit antimatter that are used to image in the technique of positron emission tomography, PET. So these antimatter will leads to different kinds of objects in the universe. But let us learn about a black hole. This is about a black hole, what you are seeing. A black hole is a region usually in the space having gravitational field. gravitational field is present, and so intensely that no matter or radiation, remember, very important, no matter or radiation including light will escape. Nothing will escape from this black hole. No matter can be escaped, light can be escaped, radiation can be escaped. Nothing will be escaped. Black holes of a stellar mass are expected to form nearly massive stars and then collapse in their life cycle. After the black hole is completed, after the black hole is formed, then it continues to grow, absorbing mass from its surroundings. That means, for example, it will act like a vacuum. It acts like a vacuum. Whenever a black hole is formed, it starts absorbing its surroundings, particles in the surroundings. The first solution of general relativity that would characterize the black hole was found by Carl Schwarzschild in 1916, and though its interpretation was a region of space and which was nothing can escape, was first published by David in 1958. And a recent organization called as European Organization for Nuclear Research, we now discuss about that. It is an organization of the nuclear research, world's largest nuclear and particle physics laboratory. India became an associate member of the European Organization for Nuclear Research, CERN, the world's largest nuclear and particle physics laboratory. In this regard, an agreement was signed by Dr. Shekhar Basu, Chairman, Atomic Energy Commission, AEC, and CERN, Director General, Dr. Fabiola Gianotti in Mumbai, Maharashtra. India will formally become member of CERN and around January 2019, already formed after depositing an instrument ratification. So India ratified this and became a member of that. And it is located usually in which discuss about this location first. It was established usually in 1954 in Geneva, Switzerland, and it has 22 member states. India is an associate member, not a direct member, but an associate member in 2017. And it is an official observer of this is an official observer of United Nations, and primary functions to provide particles. That means here it will provide particle accelerators and other infrastructure required for research in the field of physics. And after that, several experiments will be there built by CERN. It will look after that research work and experiments on the thing through very international intellectual collaborations. And as researchers want a remote access to those facilities, the lab to be known as Wide Area Network, and it became a hub. And CERN is also a birthplace of World Wide Web. Significance: as an associate member, what we can do? India can take part in meetings of CERN Council and its committees, Scientific Policy Committee and Finance Committee. And India will not have voting rights on the decision of Council. It will open up new avenues for Indian scientists to engage with their counterparts in frontline research of physics and engineering. That will boost India's science credentials and give access to high science and technology. It will also make Indian scientists eligible for staff appointments in CERN. Besides, Indian industry will be entitled a bit of CERN contracts. Thus, it will open up opportunities for industrial collaboration areas in the advanced technology. India will also has to contribute a certain amount of money for research activities, including annual contribution of 11.5 billion Swiss franc to CERN. And in 2016, CERN adopted a resolution upgrading India's position as an associate member from observer status since 2004. Prior to this, 2015, Union Cabinet had given its nod to the proposal of India's officially entry into the CERN. Earlier, because of the observer status, India was allowed to attend the council meetings and to receive council documents, but was not allowed to take part in the decision making procedures of the organization, since it was an only associate member in the CERN in 2016-17 January. Next, about the European Space Agency. What is that here? It's an organization we discussed about the 1954 Geneva, and it is there in France's border, and 22 member states is there, including India and Pakistan. But 3 international organizations have observer status, and India is only an associate member for that. As researchers want to remote access to these facilities, lab also to be has known to be a major wide area network. This is the lab hub. CERN is also a birthplace of World Wide Web. Functions we discussed already. It is in scientific instruments will be made in advanced computing and provide necessary infrastructure, and high energy physics research will be there, and it will include the particle accelerators to function the research fastly. And achievements are there here. CERN achievements: it operates Large Hadron Collider (LHC), which is the world's largest and most powerful particle accelerator. It is associated with the discovery of Higgs Boson, which is popularly known as the God particle. Indian scientists had active in construction of LHC in the areas design, development, and supply of hardware. Even we supply 11.5 million Swiss francs for CERN, and software development and deployment of machines through this money. And they also had played a significant role in a compact amount experiment, one of the two large experiments that led to the discovery of the God particle. That means India is a contributor for the discovery of God particle experiments. Next, we will discuss about Large Hadron Collider, important one here. So what is that here? It is the world's largest, most powerful particle collider. It will collide the particle, and the largest machine in the world. It was constructed by CERN in 1998 to 2008, taken nearly 10 years. By working with more than 10,000 scientists at hundreds of universities and laboratories, as well as 100 nations. It lies in a tunnel 27 kilometers in circumference and has a deep 175 meter underneath the France-Switzerland border near Geneva. So this is nearly 175 meter long underneath, and this tunnel is having a long distance of 27 kilometers. Very big. It is collider of the particles, and the major aim is, or otherwise we'll discuss that by rubbing this one. This is the large, in short it is called as LHC, and usually it has a main aim for measuring properties of Higgs. We will just see here. Main aim is that it measures the properties of Higgs boson, that means God particles, and it also searches new particles predicted by supersymmetric theories. Identify the dark matter wherever dark matter is there, and it also shows evidence of the string theory and understands antimatter. Search for extra dimensions of space, how the space is increasing, so that dimensions will be measured, and also finds that wherever the black holes are there and whether they are absorbing any other surrounding matter that it will make, and looks the signs of unification and fundamental forces. So you need to learn about fundamental forces that have shaped the universe since beginning of the time, and that will determine the fate. So here LHC experiments are many are there. In on July 4th 2020, the ATLASCMS experiments at CERN's Large Hadron Collider announced that they had each observed a new particle in the mass region around 125 GeV. It was done by the means of firing 2 beams of protons in opposite directions and smashing into each other. And then what happened? It created millions of particles. And then in a fraction of a second after a Big Bang, when Higgs field was believed to be switched on, and this was the magic. The observed particle is consistent with the Higgs boson particles. but it will take further work to determine whether or not it is a Higgs boson as predicted by the standard model or not. That means two protons in exchangingly different opposite directions were collided, and that particles were observed as God particles. Whether they are true or not, they are going to make. Other LHC experiments here, have a look. ATLAS means here a toroidal LHC apparatus. CMS means here compact muon splenoid, and LHCb means LHC beauty. ALICE, totem, LHCf, moidal, P and PB, PS, SPS. That you need to remember. And we discuss about future of this circular collider. This is what the future circular collider near the Geneva area it is there, and nearly 27 kilometers proposed, but now it is increasing to 100 kilometers, and this is having a 27 kilometer width collider particle. It goes on very fastly and can break any other colloidal particle, and that is most important for new research also. And it was proposed with a high performance also. So let us discuss about this here only. How to make here, and it was it is only proposed one, still under research is going on, and it will extend the research work also to conduct a very large hadron collider particles. Once it completes, then it reaches the end span of life. That means we can see what would be our life also will end, and it will be more than 60 miles in circumference, and cost is nearly 22 billion dollars, and completed around 2050. It will take many years, nearly more than 30 years from now. And under these plans here, it built up a stage wise it was built up. And next one, it collide electrons, positrons. You need to remember what it will do. It will collide electrons and positrons. And secondly, just we will discuss here. Firstly, it will collide electrons and positrons. Secondly, what it will do, it will collide electrons with heavier nuclei of lead atoms. And thirdly, by 2050, it will collide protons together with an energy of 100 tera electron volts. TeV in short it is called as. That means nearly 10 times that of LHC collider, very larger. And with this FCC technology, it will become a more powerful machinery for the longer tunnel, and will be able to observe particles that remain invisible in the current technology, which are invisible particles are there, and that will be declared here. And after that, FCC, this FCC researchers would like to get the better understanding of antimatter, and understand about the nature of dark matter, and again figure out God's particles existing or otherwise where they are more found to be, and having much lighter, and many research work need to be conducted to understand God particle and or otherwise Higgs boson particles. vIjAyS Darshan, minimum time maximum marks, fit to IAS, survival in IAS. We must always be ahead. Subscribe now, share now, like now.